In this video, we're going to talk about the multiplication principle. So in this example problem, we have Dunkin' Donuts and they sell coffee in 4 sizes: small, medium, large, and extra large. They also have 4 kinds of coffee, as you can see in the picture: original, salted caramel, white, and Dunkaccino. And there are 7 different kinds of flavor shots that you can add to a coffee. And they are here on the inside ring: French vanilla, blueberry, coconut, caramel, toasted almond, hazelnut, and raspberry. So our first question is, how many different ways could you order a coffee? Keep in mind that you do not have to add a flavor shot. So we have 7 different kinds of flavor shots, but really you can think that there are 8 possibilities for flavor shots because you could possibly get none of them. So you could get one of each of the 7, or none is kind of an 8th possibility. So we have 4 sizes, and we have 4 kinds of coffee. Now, if we think about those 2 characteristics alone, we can make 16 different coffees. You could think about making a table where you have the sizes along the top and the kinds of coffee along the sides. And then it would be a 4x4 table, so there would be 16 possibilities. You could also think about going through them. For each size of coffee, there are 4 choices for the kind of coffee. So if we have small, we could have a small original, a small salted caramel, a small white, a small Dunkaccino, and then we go through medium. We could have medium original, medium salted caramel, medium white, or medium Dunkaccino, etc. And either way, you should be able to recognize that there are 16 total possibilities. So we have 4 sizes, and we have 4 kinds of coffee. And that gives us 16 possibilities in terms of the size and the kind of coffee. Now we can do the same thing when we think about the flavor shots. So once we've chosen our size and our kind of coffee, for each choice that we have there are 8 possibilities for flavor shots. So say that we've chosen a small original, we can choose one of each of these options. So we could choose French vanilla, blueberry, coconut. So there's a total of 8 possibilities for each possibility that we've already made. So for these 16 possibilities, each one has 8 possible ways to add a flavor shot. So what we're doing here is we are multiplying, hence the name multiplication principle. We are multiplying the number of choices that we have for each option. So we have 4 choices for size, we have 4 choices for kind of coffee, we have 8 choices for flavor shots, and we can multiply those together to get the total number of options for our coffee. And when we multiply those, we get 128 options. So this is 8 options for flavor shots. And that gives us the total of 4 times 4 times 8, which is 128. Now, looking at number 2, now we're adding another option. So we could add whipped cream, chocolate syrup, or caramel syrup. How many total ways could we have ordered the coffee? So for our 128 options that we have for size, kind of coffee, and flavor shot, now we have an additional 4 options because we could add whipped cream, chocolate syrup, caramel syrup, or nothing, and so that's 4 options. Now we're assuming here that we can't add more than one of these things. Obviously in a real coffee shop situation, generally you can add as many things as you within reason, and they'll get annoyed with you if you're trying to add too many things. But we're making the assumption that we're only going to add one of those 3 things, but we're not adding more than one, or we're adding nothing. Those 4 options for additional, I don't know what you would call those, additional items. So we're multiplying our 128 possibilities. Each of those 128 possibilities now has 4 additional possibilities. So 128 times 4, and that's going to give us 512. So now we're switching our context here to an ice cream shop called 21 Choices that offers 21 different flavors of ice cream, and Dontrell likes all but 3 of the flavors, all of the flavors except for bubblegum, butter pecan, and pistachio. So the basic sundae at 21 Choices has 3 sizes and includes 1 flavor of ice cream and 1 of 12 toppings. Dontrell has enough money for a small or medium basic sundae. How many different sundaes could be ordered that include only the flavors that he likes? So we're just going to kind of go through and think about how many choices we have for each option. So for size, we have 2 choices for size because we know that Dontrell only has enough money for a small or medium. So that's 2 choices. And then we're thinking about the kind of ice cream or the flavor of ice cream. We know that Dontrell likes all but 3 of the flavors, and there are 21 flavors. So that means we have 18 choices. For ice cream flavor. And again, that's because that's 21 minus 3. And then our last choice is for toppings. So for toppings, you could say, well, they could choose 1 of 12 toppings. They could also choose no toppings. So you can really say that there are 13 choices for toppings. And again, we're assuming that you're only getting 1 topping here because the basic sundae includes 1 of 12 toppings. Apparently, if you're ordering more than 1 of those toppings, then you're getting out of the basic sundae price point. So we have 2 times 18 times 13, and multiply those together on your calculator, and you would get 468 options, or 468 different sundaes. And lastly, now we're looking at ordering a cone instead of a sundae. The cone has 3 scoops of ice cream, and Dontrell is going to prefer to have 3 different flavors so that they have some variety in their cone. And we're kind of making an assumption here that all the flavors work together equally, which, in real life you might stick to more related flavors, like chocolate flavors aren't necessarily going to mix with fruit flavors, but assuming that any flavor combination is possible here. Out of the 18 flavors that Dontrell likes, he considers the order to be important. So how many 3-scoop cones with 3 different flavors are possible? So now order is important. So we're thinking about how many choices we have for the first scoop, how many choices then we have for the second scoop, and how many choices we have for the third scoop. And we know that we're not repeating flavors because we want to have 3 different flavors. So if we were repeating flavors, then it would be 18 times 18 times 18 because we'd have 18 choices for each scoop. Since we can't repeat flavors, we have 18 choices for the first scoop times 17 choices for the second scoop and times 16 choices for the third scoop. And when we multiply those, 18 times 17 times 16, we get 4,896. Or cones are possible.